Good morning. We're going to talk about direct variation, and direct variation is just a special linear relationship, essentially. It works as x goes up, y goes up also. And as x goes down, y goes down. Obviously, they are going up and down at the same rate. An example of that would be getting paid. If you work 0 hours, you get paid $0, right? If you work, let's say you get paid $10 an hour. If you work 3 hours, then you get $30. If you work 5 hours, then you get $50. So that's how direct variation works. One thing that's super important about a direct variation is that the y-intercept is always the origin. It's always at 0, 0. So that paycheck example is a good one because if you work 0 hours, you make $0. Okay? It's written like this. This is the form that you usually see a direct variation, y equals kx. But you can see it's kind of like the linear equation, y equals mx plus b. Knowing that the y-intercept is always 0, 0, that explains why there's no plus b, because it would be plus 0. So it's just this part, y equals kx. And instead of calling the slope, the m, we call it k for constant of variation. All right, and you can write k if you just need to find it as y over x, just like slope is the change in y over the change in x. All right. You can use proportions to find missing values. So for example, if y varies directly as x, and we want to find the missing value, and we know some, you can set up a proportion like this. Y over x, 18 over negative 10, equals y over 5. All right, and then you can solve that by cross multiplying. So y times negative 10 is negative 10y. And 18 times 5 would be 90. All right, and then just solve that to get y alone. Negative 9. And that is how you can use direct variations to find missing values. All right, so we're going to look at these 3 examples down here to show you some other ways you might see direct variation questions asked. Okay. To determine if something is a direct variation, you need to check a couple things. First, you want to make sure that as x is getting bigger, y is also getting bigger, or the opposite. As x is getting smaller, y is also getting smaller. So let's check that first. X's are getting bigger, and y's are also getting bigger. So this could be a direct variation. We need to check another thing. We need to make sure that they have a constant of variation. So we want to make sure it's the same. And remember from up here, constant of variation is y over x. So we're just going to divide all of these. We're going to check for k. Negative 20 divided by negative 4. That's 5. Negative 15 divided by negative 3 is 5. 5 divided by 1 is 5. And 10 divided by 2 is also 5. So this is a good sign. They all have the same constant or the same ratio, which means that our constant of variation is going to be 5. All right. Following the pattern that you see here, you can see if x was 0, y would be 5, because the pattern is times 5. So you can see if we had a 0 here, times 5, the same relationship would be 0. That gives us the 0, 0 that we needed to be sure that this is a direct variation. In order to write the equation, you just use the form y equals kx, and we know that k is 5. So y equals 5x is the equation. Of course, sometimes, probably often, k is a fraction, and that's fine. It's fine. You would just write the fraction right there. All right, let's look at number 2. In number 2, we just have 2 graphs, and we want to determine which one is a direct variation. While direct variations are linear, they form a straight line, and these are both straight lines. And the other thing we know about direct variations is that they pass through the origin, 0, 0. Well, this one does not pass through the origin, but this one does. So this one is a direct variation. Do you see the difference? All right, and a lot of times we use word problems for direct variations. The interest received on a savings account varies directly, and those words are important. That means the same as direct variation. Varies directly with the amount deposited. Gary received $55.35 in interest on the $12.30 he deposited. If he deposited $0, he would get 0 interest, which confirms that it's a direct variation, but they told us, so we're okay. All right, the constant of variation is y over x. So you have to think about which one is x and y. Well, x is the amount he deposited. It has to be. That has to be first. So x would be that number, and y would be the amount of interest. So the constant of variation is y over x. All right, and I'm going to pull out Desmos to simplify that fraction. So let me find Desmos. Here we go. Love Desmos. All right, we're going to type in $55.35 over $1,230. It gives us this decimal, but we would like it in a simplified fraction. So I'm going to press this little button right here, and it says 9 over 200. What that actually means is that for every $200 that you deposit, you get $9 in interest, essentially. All right. So now we need to know how much interest he would earn if he deposited $2,000. To do that, we're going to set up a proportion. So we're going to use our constant of variation, 9 over 200, and set it up with, we want to know the amount of interest was y, over the deposit. All right, so we need, I was recycling paper. Apparently that wasn't the smartest thing to do. Okay, so we're going to need to solve this proportion by cross multiplying. 200y equals 18,000. Divide by 200. Y equals 90. So if he deposits $2,000, he will get $90 in interest. All right, I hope that you get a good understanding, and if you have any questions, let me know. See ya.